So today, Chapter 5, Lesson 4 is Terminating and Repeating Decimals. The first thing I want you to do, the first thing I ask you to do is write down the definitions of the highlighted vocabulary. Any number that can be written as a fraction is called a rational number. Okay? So here we have any number that can be written as a fraction is called a rational number. And every rational number can be written as either a terminating decimal or a repeating decimal. A terminating decimal stops, okay? A repeating decimal just goes on forever and ever and ever. Kind of like a terminating decimal would be like 0.25. Done, right? Repeating decimal, 0.62626262. You hear the pattern? The 6-2 repeats and goes on forever. Is everybody clear with that?
Yeah.
All right. So a terminating decimal stops and a repeating decimal goes on forever. So for the first example here, first problem here, it says write a decimal to represent the shaded portion of the figure. Now, here on the shaded portion, we've got 1, 2, 3, 4, 5, 6 pieces in the whole circle, and one is shaded. So what is the fraction going to be? 1/6. So that's going to be 1/6. Now, you guys remember how to change a fraction to a decimal? We're going to take the numerator and divide it by the denominator. And we're just going to show that using long division. So we've got 1 divided by 6. Okay? Now, of course, 6 can't go into 1, right? So we need to add a decimal, and then annex a 0. So we have 6 goes now into 10 one time. 6 times 1 is 6, and then we subtract. We get 4. Then we can annex another 1 and annex another 0. So 6 goes into 40. 6 times, right? 6 times 6 is 36. And then we subtract, we get 4 again. So let's see what happens. If we annex another 0, that's 40. 6 goes into 40. 6 times. 6 times 6 is 36. If I subtract, what am I going to get? 4 again. If I add another 0 and bring it down, it's going to be 6 goes into 46 times again, right? So you can see what the pattern is, right? So when we write this as a decimal, we're going to use a thing called bar notation, okay? And what that is that we are going to put a line over the number that repeats, the part of the pattern that repeats. So here, because the 6 is the repeating part, we're going to put 0.16 with a bar notation over the 6. Is everybody clear with that? All right. So for the next example, it says, which of the following fractions is equivalent to 0.3 repeating? And then we want to select all that apply. So let me see. If I did the division for 1/3, if I do that long division and I do 1 divided by 3, what am I going to get here? We have to annex a 0, right? So 3 goes into 10 3 times. 3 times 3 is 9. And then we're going to subtract, and we get 1. Right? We get 1. And then we're going to annex a 0 and bring that down. And then 3 goes into 10 3 times. So that's 3 times 3 is 9. And we subtract, and we're going to get 1. And if we bring down another 0, it's going to be the same thing, right? So it's going to be 0.3333333. So when we write it, 0.333 and ... that goes on forever. The way we write that is 0.3 repeating. which is what we're looking for right here. Is everybody with me? So 1/3 is equal to that 0.3 repeating. You got me? So now, what other of these fractions is equal to 1/3? Is 3/9 equal to 1/3? Yeah, that's equal to 1/3 if we simplify, so that one is equal to 0.3 repeating. How about 3/10? No, 3/10. How do I write 3/10? 3/10. Well, as a decimal, it's 0.3. Is there any repeating going on there? No, that one is a terminating decimal. So 3/10, that is not equivalent. And then what about 11/33? That is also equivalent to 1/3, which is equal to 0.3 repeating. All right, so rational numbers. You don't have to write this again because you just wrote it down. Rational numbers are numbers that can be written as fractions. And when I say as fractions, I don't mean mixed numbers. I mean A over B. Okay? If you can write a fraction, then it is a rational number. Now I want you to take a look at this diagram here. We know what whole numbers are, right? Whole numbers, if we look at the number line, okay, if we look at this number line, we put some lines on here. Let me pause this. So here we have a number line, okay? Now, if we're looking at the whole numbers, we know whole numbers are 1, 2, 3, 0, and going on forever in the positive direction, right? So those are the whole numbers. Now those whole numbers are included in the integers, right? Because the definition of the integers is all of the positives, their opposites, which are negatives, and 0, right? So whole numbers are part of integers. That's why they're inside the circle of the integers. Does everybody see that? Okay? So here, those are the integers. Does everybody see that they are the numbers that fall right on the tick mark there on the number line? If we go in between, what do we have in here? 1/3, 2/3, 1/2, 1 1/3, 1 2/3, and so forth. Is everybody with me? Those are the fraction or the decimal pieces. Is everybody with me? Because 1/2 is in there. That's 0.5 or 1/2. Got it? So the decimal parts and the fractional parts are the rational numbers. Any number that can be written as a fraction is a rational number. Now, does everybody see rational numbers in the big box? Integers are also included in the rational numbers. Can I write an integer as a fraction, A over B? Yeah. Can I write 5 as a fraction? Yeah, you just put it over 1. Or you can write 10 over 2. That's also equal to 5, right? Okay? So if you can write a number as a fraction, it is a rational number. Is everybody clear with that? And the same thing goes with the whole numbers. You can just put those over 1, and then it's A over B, which is what we're looking at here algebraically. A over B is how you write your fraction. You got it? All right. All right. So here, fractions, terminating, and repeating decimals, percents, and integers are all rational numbers. Now, here, every rational number can be expressed as a decimal by dividing the numerator by the denominator. That's the top divided by the bottom, right? Numerator divided by denominator. So here, if I did 3 over 10, if I divide that, that's going to give me 0.3. 0, 0. If I keep on annexing zeros, it's going to be 0. So if you look at it as a repeating decimal, it's the 0 that repeats. But if the 0 repeats, do I need those trailing zeros? No, you don't need the trailing zeros. So when you take away the trailing zeros, that makes it a terminating decimal. Is everybody clear with that? Okay, same thing with 4/5. Terminating decimals are unnecessary. That's going to be 1/8. I'm sorry, 0.8. 5/6, when we do that division, 5 divided by 6, we get 0.8333333 repeating, right? So this is, it doesn't terminate. The way we would write that is using bar notation. Please make sure you write down this definition also. To indicate the number pattern that repeats indefinitely, we're going to use bar notation, which is a bar placed over the digits that repeat. Okay? So for example, here, if we have 0.54545454 and going on forever, the 5/4 is the part that repeats. So when we write that as a repeating decimal with bar notation, we write 0.54 with the bar over the 5/4. Is everybody clear with that? Over here, we have 0.5833333333, right? What part repeats there? Only the 3. So when we write that using bar notation, we have 0.583 with the bar notation just over the 3. So for example 1, we want to write 5/12 as a decimal. So here we're going to divide numerator divided by denominator. So 5 divided by 12, that gives us this answer right here. So 0.4166, and it's going to keep on going, right? So what part repeats? The 6's repeat, right? So when we write that as a repeating decimal, the bar notation only goes over the 6. Got it? All right. So let's do some examples. So here, for the got it's, we want to write each fraction as a decimal, and we want to use bar notation if necessary. So when we are changing 1/6 to a decimal, we're going to divide numerator divided by denominator, right? So that's going to be 1 divided by 6. When I say 1 divided by, remember the divided by goes on the outside of the house, right? On our long division. So we have 1 divided by 6. And now we can add the 0 and add the decimal and then annex a 0. So we need to bring that decimal straight up. What goes in front of the decimal? 0, because 6 goes into 1 0 times, right? So how many times does 6 go into 10? Once. 1 times 6 is 6. And then we subtract. 10 minus 6 is 4, right? And then we're going to annex a 0 and bring that down. So now how many times does 6 go into 40? 6 times. 6 times 6 is 36. And then we're going to subtract. We get 4 again. Oh, we did this warm up. We did this on the warm up, didn't we? All right. So here, let's just finish it. So we're going to annex another 0. And now 6 goes into 40 6 times. 6 times 6 is 36. Now if I want to just make sure, I'm just going to go one more time, okay? So we subtract. If we annex another 0 and bring that down, we're going to get 40 again, and 6 goes into 40 6 times. So now this is going to be 36. And then you can see there's another 4. Does everybody see this? 40, 40, 40 in the long division part. Up here, what's the repeating part? The 6. So when we write this as a decimal, we're going to write 0.16 with bar notation over just the 6. Is everybody clear? All right, let's do letter B together. So here we have 8/9. 8/9, we want to divide numerator divided by denominator. So that's going to be 8 divided by 9. So 8 goes inside and 9 goes on the outside. And now we can add our decimal, bring that straight up, and annex a 0. How many times does 9 go into 80? 8 times, very good. So 8 times 9 is 72, and then we subtract. And then 80 minus 72 is 8. What do you think is going to happen? Okay, annex another 0 and go. How many times does 9 go into 80? 8 times. 8 times 9 is 72. When we subtract, what do we get? 8 again. So if I annex another 0, 9 goes into 80. 8 times 9 is 72. It's going to keep on going on forever, right? So how am I going to write this decimal? 0.8 with bar notation over the 8. Very good. How about you guys do letter C on your own? All right, so 2 divided by 11, what repeats there? 0.1818. You see, so the repeating part is the 1/8, right? So when we write that as a decimal, we put 0.18 with bar notation over the 1 and the 8. Is everybody clear with that? All right, so now we're going to write a negative fraction as a decimal. We're going to write a negative fraction as a decimal. Now, when writing negative fractions as decimals, the process is exactly the same, okay? There's no difference except that one little negative. Here, you're going to divide as with positive fractions, and then when you finish your division, then you're just going to write that negative in front of the decimal. That's it, okay? That's the only difference. So here, if we're going to do -2/9, and we're going to write that as a decimal, we're just going to divide the 2/9. You see? Just divide the 2/9. And we end up with 0.22222 repeating. So when we write that as a decimal, we're going to write 0.2 with bar notation over the 2, 0.2 with the bar notation over 2, and then we'll apply the negative afterwards. In example 3, we're going to write -2 2/3 as a decimal. So here we have two different ways. So this is how they show you how to do it in the textbook. So you're going to first change the 2 2/3 to 8/3. You're going to change it to an improper fraction. Then you're going to divide the 8 divided by 3, and you're going to get 2.6 repeating. So that's going to be 2.6 with bar notation over the 6, and then you apply the negative. Is everybody with me on that? Now, you can also do it this way, okay? So this is an additional way you can do it. You can separate the whole number part and the fraction part. So here you know it's going to be a -2. So you know it's going to be a -2, and then you have the decimal part that comes from the 2/3. So you're just going to separate the -2, and that's going to go in front of the decimal. Does everybody see that? Then you have your decimal part, then you figure out 2 divided by 3. When you do 2 divided by 3, you get 0.66666 repeating. So that's going to be 0.6 with bar notation over the 6. So here you have the whole number part, or the integer part, and then over here you have the decimal part. and you end up with the same thing. All right, so let's take a look at the got it. Here we want, for problem D, we want to write each fraction as a decimal and use bar notation if necessary. So here we have a negative 1/4, negative 1/4. So that means we're going to divide 1 divided by 4. 1 divided by 4. So we're going to add our decimal and annex a 0. Don't forget to bring that decimal straight up. So how many times does 4 go into 10?
2.
2 times. So 2 times 4 is 8. And then we're going to subtract. And we get 2. And then we'll annex another 0. How many times does, and bring that down, how many times does 4 go into 20? 5 times. So 5 times 4 is 20. And we have 0. If I annex another 0 and bring it down, I'm going to get 4 goes into 0, 0 times, right? And then I'll have a 0 as a remainder. And then I'll just keep on adding zeros, right? So, remember, when you have a repeating 0, that means it is a terminating decimal because you don't need those trailing zeros, right? So this does not repeat, does not go on forever. So this is going to be 0.25. Is everybody clear? And of course, this is also a negative. You got that? Very good. So this is a terminating decimal. You don't need to use bar notation. You got it? So for problem E, we're going to divide 5 divided by 6. So we have 5 divided by 6. So we need to add our decimal and bring that straight up. And then we need to start annexing zeros. So when we annex this 0, 6 goes into 50 8 times. So 6 times 8 is 48. And then we'll subtract. And then 50 minus 48 is 2. And now we're going to annex another 0 and bring that down. So 6 goes into 20 3 times. So 3 times 6 is 18. And then we subtract. And then we get a 2. And then we bring down, we annex another 0 and bring that down. So 6 goes into 20 3 times. So 6 times 3 is 18. And look at what's happening. When we subtract, we're going to get another 2. And then if we annex another 0 and bring that down, you'll see 6 goes into 20 3 times. You see what the pattern is. 6 times 3 is 18. So we're going to write 18 right here. And then we can subtract. And you see that you're going to get 2, and it's just going to keep on repeating. So what we have here is 5 divided by 6 is going to give us our 0 point. Because you don't forget, you want to make sure you want to add zeros before the decimals, right? So this is going to be 0.83 with the repeating bar notation over just the 3. And then of course we want to make sure we don't forget to apply that negative to the decimal. So there's our final answer. So how about you guys try letter F, and I will pause the video and you can check your answer afterwards. So for example F, this is one where we were going to separate the integer part and the fraction part. So when we separate the integer part, we can just go ahead and write the -2 in front of the decimal. And then we'll just go ahead and divide 1 divided by 6 to get our decimal part. So when we did that, we end up with 1.666, and it's going to go on forever here. So we end up with 0.16 The 6 is repeating, so the bar notation only goes over the 6. Now, please make note, you have to make sure that you don't accidentally extend. You need to make sure you're nice and neat, and you do not extend your bar notation over the 1 also. So it's just the 6. And then for example 4, it says Frankie made 34 out of 44 free throws this season. To the nearest 1,000, what is his free throw average? So when we are looking at our decimal here, we've got, and here we use the calculator to do the division, 34 divided by 44, and we got this number right here. So we've got 0.77272727. You see that the 27 is what's repeating. So if we were going to write that as a repeating decimal, that would be 0.7727 with bar notation over the 27. But they didn't ask us to write it as a repeating decimal. They asked us to round to the nearest 1,000. Okay, so that's why we're not going to do bar notation for this, but we're going to look to the thousands place. Now, this is the tenths place. That's the tenths place. This one is the hundredths place, and this 2 is in the thousands place, which means that we need to look at the next number to tell us what to do to the 2. So the 7 tells us to round up. So this is going to be 0.773, and there's our final answer. So for the got it letter problem, that letter G, it says of 9 students surveyed, 4 said they prefer exercising in the morning rather than in the evening. Express this fraction as a decimal and use bar notation if necessary. So when we divide, we are going to divide if I write it as a fraction first, we're going to get 4 over 9. And this is what we want to divide. Okay? So we're dividing 4 over 9 because there's 9 total students in the survey, and 4 said that they prefer exercising in the morning. So that's going to be 4 over 9. So when we do that division, we do 4 divided by 9. So now we're going to add our decimal, bring that straight up, and annex the 0. So now 9 goes into 40 4 times. So 4 times 9 is 36. And when we subtract, we get 4. And now we're going to annex another 0 and bring that down. So 9 goes into 40 4 times. And 4 times 9 is 36. And when we subtract, we get 4 again. Then we add another 0 and annex another 0 and bring that down. 9 goes into 40 4 times. So 4 times 9 is 36 again. You can see what's repeating. We subtract, we're going to get 4 again. See, 40, 40. This is going to be 40 down here. 4, 4, 4. So the repeating decimal, don't forget we want to add a 0 before the decimal, is going to be 0.4 with bar notation over the 4.